Hey everyone, and welcome to the AI Research Roundup. I'm your host, Alex. Today we're looking at a paper titled VARGPT-v1.1, Improve Visual Autoregressive Large Unified Model via Iterative Instruction Tuning and Reinforcement Learning. So this work presents an advanced version of a model called VARGPT. It's designed to be a unified model, meaning it can both understand images and text and also generate images based on instructions. The big improvements here come from a new training strategy using instruction tuning and reinforcement learning, plus a much larger training dataset, about 6 times bigger than before. They also upgraded the language model part and improved the image generation resolution. And if you want to dig into the details yourself, this image actually shows the project's GitHub page. So the team has made their code available, which is always great to see. Looks like they've shared the model architecture, the code for running inference and evaluation, and even the code for the different training stages, including that iterative instruction tuning and reinforcement learning they mentioned. So yeah, pretty much everything you'd need to explore it further. So speaking of exploring it, this next image gives us a peek at what VARGPT-v1.1 can actually do. This shows a bunch of images generated by the model. You can see a pretty wide variety of styles and subjects here, like anime characters, animals, portraits, even some more abstract scenes. The paper mentions these are generated at 512 by 512 resolution, which is an improvement. It really highlights the visual generation side of this unified model, showing it can take instructions and output these kinds of images. Okay, so we saw some examples of the image generation, but how does it do on the understanding side? Well, this next chart, figure 2, actually compares VARGPT-v1.1 against several other well-known multimodal models. Things like LLAVA, QuenVL, and the original VARGPT. It's plotting their performance on a whole bunch of visual comprehension and question-answering benchmarks, like MMBench, Text VQA, VQAV2, and others. And you can clearly see VARGPT-v1.1, that dark red shape reaching outwards. It's showing significantly better results than the comparison models across pretty much all these understanding tasks. So we've seen how well it performs, but how is it actually put together? This diagram gives us a look under the hood at the architecture. You can see that upgraded QN27B large language model right in the middle. For understanding, it takes input from a visual encoder and a text tokenizer. But for generation, it uses a different path involving a multi-scale image tokenizer, which is a VAE, and then outputs through an extra 2 billion parameter visual decoder. This decoder generates the image across multiple scales, as shown, so it visually separates those understanding and generation pathways. Right, so building on that architecture, this diagram shows the iterative training strategy they use, specifically for the third stage. You see, they start with supervised fine-tuning, SFT, at 256 by 256 resolution. Then they apply that reinforcement learning technique, DPO, also at 256. After that, they step up the resolution to 512 by 512 and do another round of fine-tuning and DPO. And the last step shown here is a specific fine-tuning phase just for visual editing, also at that higher 512 resolution. So we just saw how they train it iteratively. And this figure 8, circles back to the generation side, showing more examples like we saw earlier. What's neat here is seeing the actual user prompts below each image, and then VARGPT's response, which includes both a little text confirmation and the generated 512 by 512 image. It really demonstrates that instruction following capability they trained for, taking the text request and producing the specific visual result. Going a step further from just generating images from text, Figure 9 shows something new, the model's image editing capabilities. So, unlike the last set of examples where it created images from scratch based on the prompt, here it takes an input image. You see the prompts say things like, make the image look like, or transform this image, and then it modifies that original image to match the requested style, like abstract expressionism or Bauhaus-style poster. This editing ability, specifically style transfer, emerged from that final fine-tuning step we saw in the training diagram. So yeah, seeing it handle both generating images from scratch and editing existing ones based on instructions, that really highlights the versatility of VARGPT. I think the key takeaway is how that iterative training approach, using both supervised fine-tuning and reinforcement learning, allowed them to build such a capable, unified model. It's another step towards more general, multimodal AI assistance. Well, that's all for this episode. Thanks for tuning in to the AI Research Roundup. I'm your host, Alex.